enough about server side. Let's go to the client side. There is much more to work with on the client side. The first thing is the connector interface, and this is an object that can communicate. And in the client package there is a server connector, which is a client-side connector, and then there is the server-side connector in the server package, which is named client connector. Again, the names, at least to me, are a bit confusing. But so the server connector, which operates on the client side, receives state changes, and of course the framework takes care of that. So we just need to implement an event that will update everything. And the client connector is something that sends the changes on the server side, so it prepares them to be sent. And the implementation of client connector needs to just prepare those changes. And of course, client connector is implemented by every component in the server side. So you basically do not have to do anything. Well, maybe just override the method before client responds to make sure that all your changes are written to the state. So the component connector, it's a useful subclass for all connectors that work with widgets because it contains a method called onStateChanged, which is the only method you need to implement in your own connector. And that, of course, that method receives what has changed in the state and the state itself. So our connector starts with declaration that it's a class that extends abstract component connector. And there is an annotation which specifies the server-side class we are connecting. And this is the only client-side reference to a server-side component you might find in all the widgets. So you don't do that more than just in this one particular place. And it's needed for the framework to just know what is the connector for the server-side component. Then we have these nice three methods. Of course, they are very similar if you create any other widget. So any connector, any client-side connector will have create widget, and get state. The create widget is obvious, so it uses Google Web Toolkit to construct a widget class. And then the get widget and get state, they are just shorthands for not typecasting. And then there is an implementation of a method called onStateChange, which just resizes the widget according to the number of columns and rows. Calculating how many rows and columns we need to have in the widget, then we resize the widget to fit that. We remove everything from it, then we get all the items we need to paint. We reference widgets, and then we just add them. So not much of a magic. So anything that might have changed on the server side in the state, we handle it here, and we update the widget to reference that. Now the widget itself, we want to display our components in grid. So there is a Google Web Toolkit widget called grid that just allows you to do that. And this is the whole implementation that we have. So we probably might have even just ignore that class, remove it, and then use grid as a widget. Of course, we can integrate any JavaScript component. This is some advanced magic. There is a chapter in the book about that if you're interested. Then a word that to remember that the Google Web Toolkit library is really huge. So it's very likely that whatever your widget might look like, that it's something similar at least is already created and you can reuse that. So do not reinvent the wheel, just try to reuse as much as possible from the Google Web Toolkit. Now a word about the client side. So we need to be able to configure the widget set and the styles. So this is a Google Web Toolkit module descriptor. It's located in the same directory as the server side component. Basically, the only things you need to change are underlined here. So inherits should include all the widget sets that we are using in our widget. So since we are just using a default Vaadin widget set, no third-party add-ons, we just inherit that. And this is added by default by the Eclipse plugin. And then if we want to have a style sheet to add it to our widget, then we just specify its location here. And this is relative to a directory named public in the same directory of this file. So we have to create a directory called public in where this file is located, and then we put style sheet there. Okay, so far we've gone through how do we create a server-side component, how do we update the state, how this is sent to the client side, and how the client side is updated according to that. But now we need to get the other way. So we need to be able to handle whatever happens on the client side, and we need to send that to the server side so that the logic of the component can handle those. And what we have is the remote procedure calls, or RPC. So this is a stateless communication. Something happened, we just send the information and that's it. Typically this is a button click, mouse click, key press, cursor moved somewhere, drag and drop. Google Web Toolkit has a number of those events that you can trace, and then you can invoke remote procedure call. What is different from the shared state is that RPCs work both ways. So the client can call server at any time, and this is done by just making a request to the server, and the server calls the client in the response. So if there will be no request made from the client to the server of course will not be able to connect to the client, because it needs a response to the client, and that is always done after a request to the server has been made. So the client side has to initiate the communication first. Vaadin Eclipse plugin creates a working stubs, so if you generate your own widget with the plugin, then you get the code that actually works, and you can trace what happens where and why and how. What we have from client to server RPC interface, which we have to extend in our own interface and define the methods that the client can call. For example, our server allows a method called select item at index. So the client can just call the server that, hey, this is the item I want to have selected. The server side has the implementation. On the server side in the component, we implement that particular interface and register it before we can use it, typically in the constructor. Then the client side needs to get a proxy, which will be created by the framework, and the proxy will serialize the method call to a request to the server, and then the server can of course respond to that. And we do it by creating a private variable in the widget class. There is a class called RPC proxy, which we can just use to create an instance of that particular interface. Of course, the interface needs to be known to both the client and the server side. The implementation stays on the server side only. The other way around, we have a similar approach with just the roles switched. So we have a client RPC interface which defines the methods that the server can call. For example, we might want to have a method called mark and indicate what needs to be selected and what has been deselected. The client side has the implementation in this case. Again, it must be registered before it can be used. And then the server side creates a proxy of that, and the framework serializes that into the nearest response. And we can use it, of course, by just getting the RPC proxy and calling the method and adding the parameters, and that's it. This is an example of how it's done. It contains a little trick here as well that you might be using quite often in your widgets. What we do when we are constructing the connector, then we are getting the widget and we are adding a click handler to it. So we will be listening to whatever clicks happen to the widget in the browser, so that our code, our client-side code, can capture them and react. What we get in the onClick method is the element that was clicked. Then we can use a utility method to locate the connector that was clicked. If we clicked a label, for example, then that label will be returned as clicked in this particular case. Now the trick is that we don't know the contents of the cell. So our widget handles this click, but it doesn't know where precisely or to which particular item this thing belongs to, because it might be nested. We need to locate which parent of the label. So we start with element that was clicked and we go one level up and up and up until we find something that belongs to the particular widget. And then we of course return the index of that. And then we call the server side and tell that, okay, this is the item that was clicked and please mark it as select. Or rather select this item and I don't care about what you do next. And of course, the server side should react to this particular method by updating the state and marking itself as dirty so that the client can receive a state changed in the response. Or alternatively, it can just use RPC to call the client side telling that, okay, this has been marked and this has been unmarked. Now the demo, hopefully it's working. This is our grid, so we can click it. It will mark things as expected. You can see here that actually it broadcasts some events. So on the server side, we are creating a form that displays what the item that has been clicked. There is, if we add the item, then it gets added. Of course, we can add new columns and have more items, or we can remove the columns. So you see that it works pretty nicely. And what is happening is that when we click something, the click gets registered on the client side. The client side calculates what is the index of the item that has been clicked, sends that information to the server, and then the server updates its state with recreating the components and sending them back to the client side. And then the client side, of course, in response to that, just renders the component nice. When we click add or remove grid, then since these are widgets, then exactly the same thing happens. So a button gets clicked, it registers the click, calls the server side button component that it has been clicked. That server side broadcasts all the events to all the components that might be listening on the server side, of course. One of them is the grid, which adds a new column and marks itself as dirty. That means that it should send the information to the client side for rendering. You probably have guessed that there is not that much code there, and basically everything that was related to this working version was shown on the previous slides, except the dummy setters and getters. So you can get components and widgets working together really nicely, really fast, without that much effort. Of course, it requires you to know what goes where. So all the rendering things, they go on the client side. All the logic parts, they go on the server side. As I mentioned, there are some advanced topics. We also have in Vaadin a concept of extension. So this is something else than a widget. This is adding functionality without widgets. So we can add new features to our server-side components without actually extending them, which is a good thing. And then we, of course, can integrate JavaScript libraries and components with Vaadin applications. And there is a chapter in the book about that. There is a chapter in the book about extensions as well. So those who are interested, they might want to read it. And Vaadin 7 supports migration for Vaadin 6 widgets and components. So in case you have a Vaadin 6 widget, then you can almost effortlessly integrate it with Vaadin 7 and make it work there. So okay, so we created a widget and we ensured that it works. It was seen in the browser. So what next? Well, we might want to consider sharing our magnificent creation with other people, and there is something called Vaadin Directory, which looks like this. Again, the same notice as with Sampler. It's shown in the Internet Explorer to ensure you that it works in all major browsers. What you see in the middle is the list of add-ons. There is ItemGrid here as well, so you can just go to Vaadin Directory and download the widget that I showed you. There is source code included in it, so if you want, you can just trace what has happened and what's been going on. What we have on the left is the categories and the search. We can optionally here select a maturity of plugins, so we might want to have a experimental version, beta version, stable version, or only those that were certified by Vaadin to work. So this is how it looks. Now, what it is just that it's a place for add-ons. So currently there is 320 something of them. and the number increases every now and then. So it's likely that whatever idea for a widget or component you came up with, it's that somebody probably has thought of something like that and developed it already, so you might want to check it. Quite a big number of the add-ons is already compatible with Vaadin 7 upon Vaadin 7 release, so that's a very good thing. And then there are, of course, different categories, and there are add-ons for things like components, development tools, containers, data sources, things like that. The idea of add-ons is that we are able to simply reuse the work of ours or other people. So we just download the jar from the directory, we copy it to webinflib, and now if we have Eclipse plugin and there is some client-side JavaScript related to that add-on and the Eclipse plugin is not suspended, then we will be prompted about recompiling the widget set. Otherwise, we have to do it ourselves. As I said previously, this takes time, so you can just go and have a cup of coffee or something like that. Once it's copied to the lib directory, then we can just start using it, because it gets automatically added the class path and it's available in development environment. How do we add things there? Of course, the Vaadin Eclipse plugin provides that. So we just right-click the project, export as Vaadin add-on, and then we are shown this window on the right, in which we can select the files that we want to have in our add-on. So typically this should be only the files that are related to the add-on, some perhaps documentation and nothing else. So if you have a showcase application for that, then you probably shouldn't include that. You should just include only what is necessary. It would be good if you include tests, if you have them, and of course you should always have tests for your application and for any add-on you create. Then of course you have to provide some manifest information. This is used automatically by the directory. If you upload a jar with your add-on to the directory, then it just reads the manifest and updates all the fields according to it. So there is a add-on name, version, and the directory supports multiple versions, so you can have a stable version 1 and, for example, beta version of 2, and they can all be available or not available separately with the directory interface. What you should also specify is, of course, widget sets if you use them, and then you provide the location of the jar file you want to export to, and then click finish. Once you've done that, you log into the directory, and you have to be a member of the Vaadin community to do that. So registration is of course free, and then it gives you the access to forums if you want to ask questions. But most importantly, it allows you to upload your add-ons to the directory and download add-ons from the directory. Then we click the authoring link, is on the middle left. We fill in basic information like summary, description, links. It is recommended that you provide some code samples or screenshots or some other extensive documentation that might be useful when somebody else uses the add-on. Then we provide the jar file, and as I said, there is auto detection of version number. Then we need to check the compatibility list, so there is a list of versions that our plugin works with or our add-on works with, and the browser list that we should mark that, for example, it works with Firefox, Chrome, Opera, Safari, but it doesn't work with Internet Explorer, and then we submit that. On a funny note, there is an add-on in the directory called IE6 Crash, which just does that. So if the user opens a web page or our web application with Internet Explorer 6, it will crash it. I'm not sure if there is a source for that, but you might want to check it and probably develop something similar if somebody uses Internet Explorer 7 or 8 or other browser you really hate. That's it. Hopefully I didn't go too fast through that client-side development, so the connectors and the shared state, the RPCs. I think the most important thing when you are developing a widget is what to put in the shared state and what to communicate with RPCs. This, once you develop a couple of widgets, then you get a automatic habit that, okay, this goes there and this goes there, but at times it can be confusing. And finally, hopefully you will be able to export your magnificent widgets to the directory. And now if you have a topic that you think that was not covered in detailed manner, I'm awaiting suggestions, and maybe then I can just give a little more elaborate lecture on that.